So here we are looking at level curves or contour curves. And I had mentioned these briefly back when we were looking at traces of cylinders or traces of surfaces. So level curves or contour curves are the traces specific to the z values. So let's note to get us started here that level curves or contour curves are two-dimensional curves attained by setting z equal to some constant value. So here's our definition. If we let z be the function f of x, y, and we're going to let this represent some surface in space. So then we say that the equations of the level curves are defined as follows. So we define the equation of our level curve as f of x, y is equal to k. And this is such that k is some scalar, some real number. Now this is of course the explicit notation of a level curve, but as we know now, we could also define these implicitly. So let's note that if the function is defined implicitly, so if the function is defined implicitly or in its equation form, so in other words, capital F of x, y, z is equal to 0, then the level curve is defined as capital F of x, y, k is equal to 0. And this, of course, is still such that k is that scalar value, our real number. So these are the implicit, so here's our implicit notation and our explicit notation for a level curve. And I want you to note, again, just like with these traces, that level curves are simply cross sections of the surface. And now because these level curves are specific to the z values, the level curves are cross sections of the surface parallel to the xy plane. So to help relate level curves and contour curves to the real world, I want you guys to all imagine a topographical map of a mountain range. And if you're thinking, what is a topographical map of a mountain range? I want you to Google this right now. But in general, a topographical map, also known as a contour map, is a detailed record of an area of land, giving geographical positions and elevations using contour lines, aka two-dimensional curves of a three-dimensional surface. In addition to contour lines, sometimes topographical maps will even incorporate colors. So these lines and these colors indicate changes in the land, usually specific to elevation changes. So thinking about your topographical map of a mountain range, I want you to think for a moment. If you're observing that the level or contour curves are widely spread or widely spaced out, what is this indicating? Well, this indicates slow change in a function's value or gradual elevation change. So widely spread contour curves indicates slow change in a function's value. So if we're thinking specifically of a mountain range, a topographical or contour map of a mountain range, this usually indicates gradual elevation change. So if there is gradual elevation change, this is usually indicative of a flatter region. A flatter region in space. Now again, imagining your topographical map of a mountain range, what do you think is happening if you're observing that the level or contour curves are closely spaced, or these curves are tight together? Well, curves that are tight are indicative of fast change in a function's value. Or specific to a mountain range, this is going to be indicative of rapid elevation change, and usually a steeper region. So tight contour curves or closely spaced contour curves indicate fast change in a function's value. Or if we're thinking about a mountain range, this is indicating rapid elevation change. So if there is a rapid elevation change, this usually indicates to us that our surface is steeper. So we have a steeper region of a mountain. And this is just one example. The topographical map of a mountain range is just one example of where level curves and contour curves are used.